To problem number 7 of the MIT integration book of exam 2014, which is a definite integral from x equals to 0 to x equals 2 pi of the magnitude of 1 plus 2 sine x, or the absolute value of 1 plus 2 sine x. So this is a fairly challenging problem, but if you know what you're dealing with, then it's fairly easy. So let's see how we may be able to solve this problem. So our problem, which is integral from x equals to 0 to 2 pi of the absolute value of 1 plus 2 sine x, right? So what is, for example, what is an absolute value of a function? So absolute value of function f(x) equals to f(x) when f(x) is greater than 0, but negative f(x) when f(x) is less than 0. That is the definition of the magnitude of the absolute value of a function. Okay, so 1 plus sine x. 1 plus sine x as a function will be the same function in this domain, but will become negative open bracket 1 plus 2 sine x when 1 plus 2 sine x is 0. So this is a region of interest. So let's look for that region. In other words, 1 plus 2 sine x less than 0 means that sine x twice sine x is less than negative 1, and sine x is less than negative a half. So if we are to look at our circle and we divide it into 4 quadrants, angle 0, angle pi over 2, angle pi, 3 pi over 2, and 2 pi. It means that in this quadrant, all the trigonometric functions of sine, cosine, tangent, cotangent are positive. In this domain, sine is positive, and here cosine is positive, and here tangent is positive. So sine is negative in these 2 quadrants. In other words, when sine is less than negative a half, it means that from this angle, and this is actually pi over 6 on top of pi, so this is 7 pi over 6, 2, and again this is pi over 6, another 30 degrees, and this is 11 pi over 6. So in this domain, sine x, where x is the angle, is less than negative half. So what does that tell us? What does this tell us? It tells us that our integral from 0 to 2 pi of the absolute value of 1 plus 2 sine x is equals to integral from 0 to 7 pi over 6, or 1 plus sine of 2 sine x, plus 7 pi over 6 to 11 pi over 6 negative 1 plus 2 sine x, 11 pi over 6 to 2 pi 1 plus 2 sine x. Right? So the next thing we're going to do now is this becomes x minus 2 cosine x. So let me write that C properly. Cosine x 0 to 7 pi over 6 minus x minus 2 cosine x 7 pi over 6 to 11 pi over 6 plus x minus 2 cosine x 11 pi over 6 to 2 pi. Okay, so which is equals to, as we can see here, we have 7 pi over 6 minus 2 cosine 7 pi over 6 minus 0. Let's put bracket here. 0 minus 2 cosine of 0 plus, actually minus 11 pi over 6 minus 2 cosine 11 pi over 6, close bracket, minus 7 pi over 6 minus 2 cosine 7 pi over 6. Okay, and we'll continue with the process. Maybe let's bring it up here. Plus pi minus 2 cosine pi minus cosine minus 11 pi over 6 minus 2 cosine 11 pi over 6. So our problem, just to write what we had written before, we have 7 pi over 6 minus 2 cosine 7 pi over 6 minus 0 minus 2 cosine of 0 minus 11 pi over 6 minus 2 cosine 11 pi over 6 minus 7 pi over 6 minus 2 cosine 7 pi over 6 plus 2 pi over 2 cosine pi, 2 pi, sorry, minus 11 pi over 6 minus 2 cosine 11 pi over 6. So what we see here is that this plus here and this, this negative and this negative here becomes a plus. So we have twice 7 pi over 6 minus 2 cosine 7 pi over 6. So this here and this. Now we see that this cosine 0, negative and negative here, then with this cosine 2 pi can interact with one another in a way. The 0 vanishes, so we have 2 pi and plus, this is 2 times 1, positive 2, and then we have here as well negative, so they cancel, this and this cancels out. Okay, and then we have this negative and this negative, that becomes twice. Okay, so let's becomes negative 11 pi over 6 minus 2 cos 11 pi over 6. So what we have here is 14 pi over 6 minus, there was 2 here, minus 22 pi over 6 plus 2 pi. So we have taken that, we've taken that, and we've taken that. Okay, and then next we do have plus 4 cosine 11 pi over 6, this and this interacting, minus 4 cosine 7 pi over 6. So 14 minus 22 is negative 8. So let's maybe write that again. So we have 14 pi over 6 minus 22 pi over 6 plus 2 pi plus 4 cosine 11 pi over 6 minus 4 cosine 7 pi over 6. So over 6, 14 pi minus 22 pi plus 12 pi plus cosine, so this becomes 4 times root 3 over 2 minus, this is negative root 3 over 2. Okay, so this becomes negative 8 plus 12 is 4 pi over 6 plus 4 root 3, because this becomes plus, and so we have root 3 over 2 plus root 3 over 2 by 2, 2 by 2, 3, and this becomes 2 over 3 pi plus 4 root 3. So what this is telling us is that our integral from x equals 0 to 2 pi of 1, the absolute value of 1 plus 2 sine x equals to 2 pi over 3 plus 4 root 3. So that's one way of looking at it. I personally would like to do another method that involves plotting out the function so that it's easy to visualize where to stop and where to invoke the negative sign on the function 1 plus 2 sine x. So we are looking at method 2. So our problem still remains 1 plus 2 sine x, right? And my interest here is just in plotting that function, one absolute value of 1 plus 2 sine x. So if we begin by plotting 2 sine x, so this is 2 and this is negative 2, and then if we superimpose and by the way, let's be mindful to demarcate this to be pi and this to be 2 pi. So what happens is that 1 plus 2 sine x is this 2 sine x added to 1, and so it becomes something like that. So this is 1 plus 2 sine x, right? And let me also be mindful to write this as 2 sine x. And then that line there is 1. Also to denote that this is 3. So these points here, as we previously saw, this is 7 pi over 6, and this is 11 pi over 6, such that the absolute now of things becomes this function until when we reach 0, and as we try to cross into the negative domain, it loops back. Sorry, it doesn't quite yeah, let's something like that. And then as it continues to cross back to the positive domain, it just continues as it is. So this is the area that we are required, and let me just indicate this as 1 plus 2 sine x absolute. So this is the area we're supposed to look at. Now, very important, this part, let's look at it quite critically here. This pi is supposed to come up to somewhere here, but what we're seeing is that this area here is the same as this area here, and we can actually ignore everything on the upper side. And so what this is telling us is that we can look at it from this perspective, that this integral of ours is the same as 1 plus 2 sine x without perturbing the sign from 0 to pi, and then when pi crosses to 0 on this 2 sine x, and then when we add 1 it goes up from pi down to 7 pi over 6. That area there is equivalent to what spans from 11 pi over 6 to 2 pi. So I can do 2 pi from 7 pi, to 7 pi over 6, 1 plus sine 2 sine x. And then things become, because we have to force this negative part on the actual function, so we have now from 7 pi over 6, everything has to be forced. So we've added this negative sign up to 11 pi over 6, 1 plus sine 2 sine x. So that's how our problem would be. So let's continue. Let's see how we may be able to solve that. So we've said that our problem now is 0 to pi of 1 plus 2 sine x plus twice pi to 7 pi over 6, 1 plus 2 sine x minus from 7 pi over 6 to 11 pi 1 plus 2 sine x. So this becomes x minus 2 cosine x 0 to pi plus 2 x minus 2 cosine x pi to 7 pi over 6 minus x minus 2 cosine x 7 pi over 6 to 11 pi over 6. Right? So let's rewrite what we had previously. So we have x minus 2 cosine x 0 to pi plus 2 x minus 2 cosine x pi 7 pi over 6, and then x minus 2 cosine x 7 pi over 6 to 11 pi over 6, which is equals to what we see here is, actually, let me apologize. What we have here is just pi. Okay, so when we feed it in, we have pi minus 2 cosine pi minus 0 minus 2 cosine 0. This covers this, plus 2 7 pi over 6 minus 2 cosine 7 pi over 6 minus pi minus 2 cosine pi, close bracket, minus it is 11 pi over 6 minus 2 cosine 11 pi over 6 minus 7 pi over 6 minus 2 cosine 7 pi over 6. Okay, so let's see how we may be able to consolidate things. I would like to consolidate this and this, because we have minus minus, this becomes a plus, so we have 3 7 pi over 6 minus 2 cosine 7 pi over 6 minus, then the next part is, let's deal with this one. So we have 11 pi over 6 minus 2 cosine 11 pi over 6. Okay, and then the next part is dealt with this one, we've dealt with this one, is this and this. So because we have 1 minus 2, so we're left with minus 1 pi minus 2 cosine of pi. So we've dealt with this and that. Then we have to deal with this. So this is 0, but minus minus, it becomes 2 cosine of 0 is 1, so plus 2. Now we realize that cosine of pi here is the same as negative 1. Negative 1 times negative 2 is positive 2 times this negative 1, it becomes a negative 2. Then with this, this and that would cancel. So now we come to a point where we have 3 times 7, which is 21, pi over 6, minus 11 pi over 6. So this and this, and then we have this minus pi. This is one thing. And then plus this here, 2 cosine 11 pi over 6 minus 3 times 2, negative 2, so this becomes 6 cosine 7 pi over 6. Okay. So we've come to a scenario where we have 21 pi over 6 minus 11 pi over 6 minus pi. Then we have 2 cosine 11 pi over 6 minus 6 cosine 7 pi over 6. So this becomes 6, 21 minus 11 minus 6 pi plus cosine pi over, so back to our quadrant. This is all, this is sine, this is cosine, this is t, or tangent. So 11 pi over 6 is there, so this becomes 2 root 3 over 2 minus 7 pi over 6 is here, so this becomes minus 6 root 3 over 2. Okay, cancel, 3. So this becomes now 21 minus 11 is 10, 10 minus 6 is 4, so 4 over 6 pi plus negative 3 root 3 plus root 3 becomes 4 root 3. Becomes 2 over 3 pi plus 4 root 3. So we've come back to the same answer where we have 0 to 2 pi of 1, the absolute value of 1 plus 2 sine x being equal to 2 over 3 pi plus 4 root 3. And that's the answer. Okay, I mean, I think we've pretty much, I mean, the two methods, they look pretty much the same, but just for those of us who like visualizing graphs, I think the second method would have been easier, but all the same, it leads to the same answer.